Hey there, and welcome. Every single day, you're making decisions, building arguments, trying to make sense of the world. But have you ever stopped to look at the actual blueprints behind your own thinking? Well, today we're opening up the mental toolkit. We're going to explore the two fundamental types of logical reasoning that power every single conclusion you draw. Honestly, getting a grip on these is the secret to thinking more clearly and arguing way more effectively.
So, you want to build a rock-solid, convincing argument. Where do you even start? Well, think of it like building a house. You can't just throw some bricks and wood together and hope for the best. Nope, it needs a blueprint, a logical structure that holds the entire thing up. Today, we're going to get familiar with the two main blueprints we all use for thinking.
And what's kind of wild is that you are already an expert with these tools. You use them every day, probably without even realizing it. So what we're going to do is pull them out of the toolbox, shine a light on them, and learn how to use them with real intention and precision. Our first tool is what I like to call the architect's blueprint. This one is all about structure, rules, and most importantly, certainty. It's a completely top-down approach. You start with a big established principle and you work your way down to a specific, absolutely guaranteed conclusion. The official name for this is deductive reasoning. And here's the absolute key. If your starting points, what we call premises, are true and your blueprint is solid, then your conclusion isn't just likely to be true, it has to be true. There's no other option. It is a one-way street to a certain conclusion. And the structure itself is surprisingly simple. Think of it as a 1-2-3 punch. You start with a general rule, you add a specific related fact, and boom. From those two, you draw a conclusion that just logically has to follow. Let's see it in action. Okay, take a look at this. Premise 1, all teachers must communicate clearly. That's our big general rule. Premise 2, Sarah is a teacher. That's our specific little fact. So, if we accept that both of those are true, the conclusion is totally inescapable. Therefore, Sarah must communicate clearly. See? The logic flows perfectly. This is what we call a valid argument. Now let's look at this one. It feels kind of similar at first, right? Premise 1, all teachers communicate clearly. Premise 2, Ahmad communicates clearly. Conclusion, therefore, Ahmad is a teacher. But wait a minute, that doesn't really work, does it? The structure is flawed. Just because Ahmad has a quality that teachers have, that doesn't automatically make him a teacher. The conclusion doesn't necessarily follow, and that makes this an invalid argument. And this brings us to maybe the most important point about deductive reasoning. It's all about the structure, the blueprint. An argument's structure is what makes it valid or invalid. Now, to be really powerful, an argument needs to be sound, which means it's both valid and its premises are actually true in the real world. But validity itself, that's just about the logical flow. It's a really key distinction to make. Okay, let's put the architect's blueprint aside and pick up our second tool. If deduction is the precise architect, then this next method, well, it's more like a curious investigator. This isn't about starting with a rule. It's about starting with clues, gathering evidence, and piecing together the most likely story. This method is called inductive reasoning, and it works in the complete opposite direction. We start with specific little observations, and we build our way up to a bigger general idea. But here's the crucial difference. Inductive reasoning doesn't give you certainty, not at all. It leads to probability. The conclusions are likely, yeah, but they are never guaranteed. And this whole process probably feels supernatural because you do this all the time without thinking about it. You see something happen, then you see it happen again. You start to notice, hey, I think there's a pattern here. And from that pattern, you form a generalization, or what we call a probable conclusion. Here's a perfect example. Imagine a teacher notices one thing. A lot of my students seem to like interactive stuff. Then they gather another clue. Yeah, they definitely talk more in group discussions. From these specific pieces of evidence, they come up with a general idea. Interactive teaching methods may improve student engagement. And you gotta notice that word may. It's an admission that this is probable, not 100% certainty. So, if these arguments aren't judged as valid or invalid, how do we know if they're any good? Well, we talk about their strength, and an argument's strength depends entirely on the evidence. How many observations do you have? Is your evidence even reliable? Is the pattern consistent? And maybe most importantly, is there any evidence out there that goes against your conclusion?
This slide just nails the difference. A weak conclusion takes a tiny bit of evidence and makes this huge sweeping claim. Oh, all students dislike math because a few told me it's hard. That's a massive overreach. A much stronger and, frankly, more honest conclusion sticks to the evidence. Some students find mathematics challenging based on what I've seen in class. The goal here is to be precise, not to overgeneralize.
Okay, so we have the architect's path to certainty and the investigator's path of probability. Let's put them side by side to really hammer home how different they are. This table really puts it all into perspective. Look at the starting point. The architect begins with a general rule, while the investigator starts with specific clues. The direction? Totally opposite. Architect is top-down, investigator is bottom-up. And the final result? The architect gets you a conclusion that's logically certain, while the investigator lands on one that's just probable or likely. Different tools for different jobs.
All right, we've gone over the theory, we've examined the blueprints. Now for the fun part. Let's see how these tools actually work out in the real world, in decisions you are probably making every single day.
Okay, picture this. It's a classic moment. You're heading out the door. You glance outside, see some ominous dark clouds rolling in, and you instinctively grab an umbrella. Super simple, right? We've all done it.
So, which mental tool did you just use? Were you the architect or the investigator? That was the investigator. Pure inductive reasoning. Based on all the times in your life you've seen dark clouds followed by rain, you formed a probable conclusion. It's probably going to rain again. It's not guaranteed, but it's a pretty strong evidence-based guess. Okay, let's try another one. You get an invitation to some event, and the dress code is printed right there. Formal attire required. So you go to your closet and you put on a suit or a formal dress. So which blueprint were you following that time, architect or investigator? This time, it was the architect. That's classic deductive reasoning. You started with a general rule. Formal attire is required for this event. You applied it to your specific situation. I'm going to this event. And you reached the only logical conclusion. Therefore, I've got to wear something formal. So here's really the whole point. You now have the blueprints. You can deconstruct not just other people's arguments, but more importantly, your own. The next time you feel really certain about something, just stop and ask yourself, am I being the architect here, applying a solid general rule? Or am I being the investigator, and is my evidence actually strong enough to support this conclusion? You know, being a sharp thinker isn't really about always being right. It's about understanding why you believe what you believe. So the real question is, how are you going to use these tools to challenge your own thinking?